So I guess if you're watching this having just seen a video and not without any context, we're just going to quickly demo the some of the functionality of the GitHub repo OPTIMADE Python tools, which can be used to sort of spin up an OPTIMADE server quite quickly. And there's kind of two main ways of doing this. So the first we're going to quickly show is this sort of configuration only to get an implementation just of the reference server. And I'm just going to use essentially the example configuration file, which you'll see in a second. So the first thing to do there is talk through some of these options, which is a bit dry, but we'll get through it. So the reference server uses MongoDB exclusively. You can use MongoMock to sort of fake a MongoDB server locally, and that's essentially what this flag controls. So if you use a real Mongo, then you set that to true. Otherwise, it will set up a little fake MongoMock database for you. You need to provide it sort of standard things for Mongo, so the actual name of the database you're going to be querying, the URI of where this database is, how to get to it, the collection names for each entry type. So at the moment we have 3 entry types in the specification: structures, references, and links, and you need to specify all of those. There could be an overlap here, and you could have a transformer that filters on type of the entry as well, if your backend does it that way. We then mostly have some sort of some fields to do with sort of implementation details or description. So a default DB doesn't really mean a lot if you have one database. The base URL is obviously just where the web server expects to be being served, so it can sort out all the internal URLs. And then things like the implementation, I'm just figuring out how to get rid of that chalk. Reset chalk. Yes. You can then provide your sort of provider details as you would in the provider's repository. And importantly, you want to be providing your database specific prefix here. So at the moment it just says example. And hopefully it's all fairly self-explanatory if you know the OPTIMADE specification. Get rid of that again. So onto the more sort of important ones for the actual implementation. Firstly, we have this provider fields section. So this is where you can essentially register properties or implementation specific properties of your database that you also want to serve with this server. So the way you specify it is just by endpoint. So it's a dictionary with a key for each endpoint. In this example, we have structures, and then we're just saying we're going to serve a property called bandgap and a property called chemsys. So I think these are from Materials Project at one point. And essentially what that will do is automatically create all the underlying OPTIMADE machinery to be able to query this, but using the implementation specific prefix at the start. So it will essentially allow you to filter on, in our case, example, bandgap, then just becomes a field. And if you set it up in such a way, as I'll go through in the sort of second demo, then you also get a description and a type and things added to that, although this is sort of ongoing work in the specification as well. So that's quite useful. Another useful thing is this Aliases field. So this is just when you want to very simply just change the name of an OPTIMADE property. So in the structure example I'll show you in a second, the database had a task ID. Obviously that isn't the actual OPTIMADE field, but if you apply this alias of just ID, then as long as that field obeys the same rules as the OPTIMADE field, everything will sort of happen automatically there as well. So it will be checked that it's unique and so on, and that it can be validated as an OPTIMADE ID, which has some sort of a few rules on the actual string underneath. And likewise for these chemical formula properties, they're just sort of simple renames. Then there's this length alias, which is kind of specific to, at the moment it's specific to the MongoDB transformer, but if you were to implement a different backend, you could also use the same functionality. So I think I mentioned this in the other talk, where you can essentially provide a field that acts as the length of another field. So the example here is a bit of a weird one. So chemsys is already a provider field, so that does work. But maybe as a clearer example, you could think of You could think of this being the list of positions, so it could be Cartesian site positions, and then the obvious length alias would be n sites. So that way, when you're performing a query that's like length Cartesian site positions greater than 3, instead of looking at or going through the database, computing the length of every field, or checking an index for that, and then comparing those, it will just directly compare the integer field n sites, or n elements in this case, which could be sort of quite a large optimization for a lot of backends. So that's kind of an overview of all the settings, and it kind of goes back to what I was saying about. 1 second, Casper. It kind of goes back to what I was saying about whether your backend sort of very simply maps onto the specification. So if you can get away with it, so I think this is what Materials Project are doing for now. For example, a lot of their fields already very closely match the specification, so they can just sort of spin up this example server, and then if not, I'll show you this sort of a slightly more advanced method that extends the models directly in a second. Sorry, Casper, what were you raising your hand for?
Just to say that this is the very explicit configuration file. So there's a lot of defaults for this. Yes. Personally, in AIDA, we don't use MongoDB, we use AIDA. And so there's a lot of the first ones that you don't need to put in. And if you miss out length aliases, then there are no length aliases. It's just an empty dictionary. And so there's a lot of fallbacks for these. And so it can be very minimalistic in the end.
Yeah, exactly. I mean, I think the default config on the repository shows you the defaults, so empty aliases, basically empty provider fields. And obviously, as you said, if you're not using Mongo, then they'll just get ignored, and that's fine.
Yeah. There is a nice feature as well for the implementation, which is that it doesn't show here in the implementation, but there is a version field as well. But here it just passes through the version of the repository of the package. So when you update and release a new version of the package, that will also show in the configuration and in the responses automatically. It's really nice.
Yeah, so we can show that an example when we actually spin up a server in a second. So I just thought I'd go through a sort of kind of noddy example of this. So let's just say you have a database that has nearly matching OPTIMADE structures. So this is just one entry. I guess the chance of you representing your dimensions in this particular way is probably quite unlikely. So it's not exactly the best example. But in this case, the only difference is that the name of some of these fields and also these extra provider fields that we're going to provide. So what I thought I would do, that's the next one, is just quickly show how this works. Don't even know what folder I'm in there. So essentially all I've done here is take a copy of the main server code, which I've put in main. I changed a couple of things that are completely irrelevant just so it runs in this demo on this new sort of structures file. But this is the file I just showed in the presentation. I've also got a references file. So you'll see that in the structure, we have a link to a bibliographic reference. So the references file just contains, I think this is the one that's actually used in the structure. So just a very simple references entry. And what we're going to do is quickly go through this config file, which I'm pretty sure I'd already set up. So yeah, I changed the implementation to just like CCAM 2020 or whatever. We're not going to use a real Mongo, we're just going to do it in memory. And we have these aliases set up already, so this is what I should have added. Pretend I hadn't written those. So the only difference in our case is that we need to set up the alias to n sites, which if I open the structure again over here, is that still big enough for people to see? Just nod rather than, yeah, cool. So you'll see this, we have this num atoms field here, which is the wrong name. So we're just going to quickly add the alias to that. We also have, we also have positions cart rather than Cartesian site positions. do shout out if you see me making a typo as I do this. I thought it'd be more instructive to do it slightly more live. We already have band gap as a provider field, and we already have chemsys as a provider field. And hopefully this should all just work now. What I'm actually going to do is delete a field, so you actually see what happens if you don't have the right fields as well. But now from that config file, what I'm going to do, so specifying the OPTIMADE config file environment variable, we're going to run the Uvicorn server on the app. Let me just tell it the port. And all of this, if you're running it from the actual development repo, you would just use the run script, which essentially does this for you. But now if we execute this, we'll get some blurb that it's loaded stuff into MongoMock, it's loaded the links, it's loaded, okay, so this is something I guess Casper wants me to say, it's loaded the providers from optimade.org onto the links endpoints, and I'll definitely make a point of talking about the index database at the end of this. We're loading test references, we're loading test structures, and now we have an actual web server running locally. So let's open this link. We get a default landing page, and this kind of goes on to what Casper was just saying. So it's using the version of the spec internally for the actual Pedantic models. It will generate that for you and sort of put that all throughout the server. So that, for one, means we can actually look at different versioned URLs, unless I deleted that part. So, oh, I think I did delete that part from the app. Oh, that's really upsetting. Let me quickly see if I did. So I didn't want to overcomplicate it, but now I do want to overcomplicate it. So what I've done is re-add something I've previously deleted from the main app code, start the server again, and wait for it to load, unless I've just crashed it. No, good. So now we can specify the actual OPTIMADE version. So this is the version of the specification used by the server, and all URLs essentially of any Semver compatible version of the spec should work. So because we're on version 0.10.1 of the specification, any sort of subset of that version is going to work. So, for example, if I put 2, we're told that, well, maybe we should have a nicer error message that in fact that version is not yet supported, but at the moment it just throws an exception. And as Casper was saying, this is telling us that we're using version 0.7 of the Python tools. The reason that says 0.7 is because I've got it installed in like an editable way with pip. So this version number is actually wrong for my particular machine. If you install it today, fresh, this should say 0.8.1, I think we're up to now. But you also get links to the available endpoints. So just to quickly sort of tour these, the best one to start with is probably info. So if you guys can hopefully read this, all of the OPTIMADE specified response for the info endpoint is generated for you just from that config file. So API version, again, is just the version of the spec we support in a couple of different places there. The available endpoints are all filled out. And entry types and whether it's an index database, all of the meta info. So when we actually did the query, so that time is correct in UTC. And then whatever info you provided as the actual provider details will appear here as well. So we can then also look at info structures. You probably can't read the URLs I'm typing, I'm sorry about that, but all I've done is add structures to the end of that last URL. And essentially, if I collapse it, open it up again, this has now filled out the info endpoint for the structures entry type. So this gives you essentially the specification and any extra fields or any extra things related to that, the info. So that this is at the moment just directly copied from the specification. So if you were to open this in Swagger, you'd get nice formatting, but unfortunately we just have plain text here. And one thing you'll notice is actually that the provider field that I specified isn't available here. So this is an ongoing sort of pull request we have. So at the moment you have to extend the model directly with Pedantic in order to get your provider fields to appear in info. But that's hopefully a work in progress this week. And that's probably enough just looking at JSON. It's probably more exciting to actually try query things. So what I'm going to do now is look at an actual structures endpoint, and I'm expecting this to fail and hopefully with a useful error message. And oh, I put an extra slash in so it didn't fail. There we go. So that's a very unhelpful rendering of the error message. Thankfully, we can see it in the server instead. So I just tried an empty query, which essentially tried to hit every single structure we have. And this is, I think, where the Pedantic models are really, really powerful, because we're told immediately which parts of our server were incorrect at that point. So we're told that the Cartesian site positions are missing. We're told that nsites is missing. We're told that it couldn't verify species at sites because nsites was missing. So there's lots of sort of links between the properties of how we do the validation. And then finally, we're told the structure features is missing, which is the one I was expecting because I just deleted it. So what we have to do now is go back and change our config file.
So this is done by the validator?
This is done. So this is a separate validation done by the actual model itself. So this is separate from the validator that runs in the GitHub action, for example. They use the same thing, but this is essentially just loading the structure response into the models we use to, well, in this case, to create the structure response. And yeah, finding that there are fields that are missing or fields that didn't obey all the rules we set out for them. So all we need to do is sort of edit our thing here. So this is, I guess, equivalent to adding the field in your backend. We're going to add structure features. Let me just open the config as well. So did I get all of these correct? Nsites, num-atoms. Okay, so those should be working now. Cool. So now we just reboot our server. So I think the reason there were extra errors that time, even though I'd already set up the aliases for num-atoms, is because I didn't tell it to use this config file, so it was actually using my default. So hopefully this time everything will actually work and all the errors will be fixed. It's not just magic, it was just me messing up. So now we refresh the same query. We get one response, which is what we expect, because our backend is just a JSON file with one structure in it. And we have all of the specified fields by OPTIMADE. Pretty boring versions of them, just one atom of actinium, I guess that is. And obviously we can just look at the actual response itself. You'll notice that the provider fields have, as I said they would, have had this example prefix already added to them. And in fact, if we start now doing queries on this, so all I'm typing is !filter equals example bound _ gap. Let's say less than 1.20. So this structure will now be excluded. So you'll see now there's an empty response for data. 0 data returned, 1 data available. That's our whole database. And then if I change the number to less than 1.25, hopefully the thing reappears. So this is sort of straight away enabled filtering on the provider field. I mean, it's quite a simple field, obviously, but if you have already set up your transformer in such a way, then it should all just work from the URL. Okay, so that's kind of this configuration approach, which hopefully you can see is already quite powerful. Oh, sorry, Casper's got his hand up again.
Sorry. No, I just want to add that we also have the specific single entry endpoint. So you
yes.
could also slash the ID, which I think is very relevant for Yukari. So that's the exactly. So the whole URI will act as a UUID actually for that resource.
Yeah, that's a very good point. So yeah, as Casper just said, again, hopefully you can read at the top here. I've just added the ID of this phase of this structure. Sorry. So mpf_1. If you literally just do /mpf_1, then we get the single response or single structure response, which instead of providing a list under data, it just provides the actual structure itself. So that's that. So I think you can probably move on. So the other approach I mentioned is actually extending the Pedantic models yourself and perhaps using or writing your own versions of the app code. So I'll just briefly talk about that. So this is just a quick example that the thing you're probably going to want to extend, or one of the things you might want to extend, is the structure resource attributes. So this is a way that you could provide a more complicated structure field that you actually want to be validated as well in your own database, and also provide the schema for that in the entry info endpoint, so at info/structures. If you set it up this way as a Pedantic field, then you sort of get that for free as well. So if I maybe just fold some of these a second so we can concentrate. So all you need to import really are a few parts of Pedantic. So the actual field, which is how it generates sort of instances of properties. We're going to validate one of our fields. So if you know Python, this is just a decorator on a class method that validates that particular field. We're using some of the standard library Python typing to define a dictionary and a list. And then we import from OPTIMADE itself, we import structure resource attributes, which is the sort of the base class we're going to take. Structure resource, which is the container that also includes the UUID. And also a structure mapper, which if you were in the talk earlier as well, you would have seen this structure mapper sort of is a go-between from the filter to the entry collection, and then also from the entry collection back out to the response. So it allows you to tweak field names in your filter in order to pass it to your underlying database. And it also allows you to map your database response back into an OPTIMADE compliant document or entry. So hopefully this bit is just to show how easy this is. This is almost exactly the same code as what I have in ODBX, just with sort of sillier field names. So let's say you wanted to define an entropy for some reason. It could actually be an entropic contribution to your total energy, like a vibrational entropy. You just say, I want a field. You essentially say, I'm not going to give it a default value. It has to be specified. And if you write a little description, this will get passed up to the entry info endpoint. This is what will actually be displayed. And we essentially just give it a type. We say it's a float, and that's everything. It will now be able to be filtered on. It will now be able to be queried on. It will be sortable by default, for example, and all the sort of machinery there should work. And it will still be given your database specific prefix, because the server knows about OPTIMADE itself. It knows these structure resource attribute models are from OPTIMADE. Oops. So it will only use fields. Any fields it finds that aren't part of those underlying models will be given this prefix, just to avoid sort of polluting the namespace and actually sort of being spec compliant. Then the other slightly more complicated one I've defined here is just a pseudo-potentials dictionary that takes a string and gives out a string. We don't have to worry about that too much. So to validate your field, say you write this little Python decorator, you pass it the actual field name or property name, and you just write a little function that essentially throws an error if the field isn't what you expect. So in this case, if we give it an entropy that's negative, so we're asserting that the entropy is, in fact, we should actually say whether this is greater than or equal to 0. And if this isn't the case, then we're going to say that something's gone wrong, and we're going to raise an error. We then just very simply extend the structure resource class to use our new attributes class. So it's kind of just a bit of boilerplate, really. And in our structure mapper, we can then give a list or a set of provider fields that we want to add to the response. So if you don't add this here, then essentially it just won't appear in the response. If you do add it here, it will appear with the your provider specific prefix. Okay, so this is all being executed in my browser, so that should actually work in a second. When I pass it some load of data. So here I've just defined, again, a very sort of minimal structure for sodium chloride. there's hopefully a decent chance that most of these fields already exist in your database. But in this particular case, we've now added an entropy of 10 and a pseudopotentials dictionary. I'm not quite sure why that says dic there. A pseudopotential dictionary that just sort of lists a file name that you use for the pseudopotential. So if we try and make this object, let's say with a negative entropy here, or in fact, okay, let's start with a better example. Let's make it with a missing OPTIMADE field. Then straight away, we get a big error that structure features was missing. We also get an error that our new entropy field is missing because we defined that as sort of a necessary field. So let's add this back in. And now let's try and give it an entropy that's negative. And you'll see we now get a different error with our custom error message that we've broken some fundamental law. But hopefully if we give it a positive entropy, everything just sort of goes through. And the good thing here is that we can then also generate a schema directly from this. So again, it's not particularly nicely formatted here, but if you've extended the models, then this is essentially what the Swagger documentation will show. And if I search for entropy, you'll see the field we just defined very simply in that class there. Okay. So as this is being recorded, I may as well just quickly talk about a couple of case studies of real implementations using this. So the first one will be ODBX, which is sort of my database. And this is a very simple, it follows very close to the actual OPTIMADE Python tools implementation. I actually made the database directly from the Pedantic models. So the first step was taking our initial database, pushing them through the Pedantic models and validating them there, and then making a new database, which was essentially just the JSON of the OPTIMADE models. We could do that because we had no real investment in the underlying data structure we had, and we didn't necessarily want to make that public. So what I've said here is that OPTIMADE Python tools is used both for the REST API and also for HTML. We have a very simple tech stack of just, we have a Docker container that runs Unicorn for the REST and for the HTML. We just have some sort of load balancing and routing with Nginx, and then we have MongoDB as well. These are all sort of very, very easy to set up in this framework. You just pass things around as either with Unix sockets or with ports or whatever you want, really. And as I said, we made it essentially a new database, or a curated database that we wanted to make public from our existing MongoDB, just using the entry mappers in a more sort of generic way than actually inside the server. And I'll hopefully just show that the code isn't particularly difficult or isn't particularly complicated. There's a fair bit of sort of like boilerplate for just running a web server generally. But the model extension part itself, if we look at our extension to structure, again, do let me know if you can't read this, but we just have a few provider fields implemented, the ones that sort of make sense to us. These don't necessarily ever have to match up with the specification, but if we already had them, we may as well provide them. So things like just the actual lattice parameters rather than lattice vectors, things like fractional coordinates, cell volume, and then these extra sort of container classes for example, DFT parameters and for thermodynamics. So if I see how smart GitHub is nowadays and go there, you can see that this container just contains things like enthalpy, total energy, formation energy, things that people might feasibly want to filter our database for in particular. And yeah, hopefully you can see it's just very, very simple to specify these things. And yeah, if I maybe quickly show the app code as well. So my app code is actually even simpler than the reference example. It's just setting up fast API. Sorry, this is for the HTML part of the actual website. So very, very easy to spin something off the reference implementation that's even simpler. So in my case, these routers just point to, if we look at the structures router in particular, they do a very similar thing to the default OPTIMADE routers, but instead just return this sort of templated HTML response. So here's the error one, or no structures found, but you kind of just pass it the data, and just to show you what that looks like. In one particular example, it will just generate a nice sort of thing for you. And here we've used a part of the Python tools, the adapter, to be able to export a CIF very easily. So exactly the same as what Casper showed for his clients, except I only have one option. Maybe in the future we'll have multiple options. But it's just it felt very easy as someone who wasn't particularly experienced with web, just to use the OPTIMADE Python tools to generate this from a more sort of sciencey background of just making a database. So that's me. Another case study that I won't go into because it's probably it's definitely more Casper's domain, but you can have a good look at another sort of open source implementation of this, which is for AIDA. And here they used OPTIMADE Python tools to actually power multiple databases at once. And they do not use MongoDB, so they've actually had to write custom transformers and a custom entry collection that convert to AIDA's internal method. And I won't say that whether that was easy or not. I guess that's up to Casper to say so, but I think the fact that they chose to do it that way is probably a good sign. And it seems like the Python tools can provide quite a general base for spinning up servers and for making sure your implementation is sort of solid. And one thing I forgot to do actually, I think if the server is still running, which it is, we can quickly show the validator. So I can run this locally. So we're going to run the validator on the versions URL, just running at port 5000 for me. And everything happens very quickly because it's local. You'll notice there's output on sort of every single query that happened. I'm not sure why that's given such a verbose output. Something's gone a bit strange there. So I'd expect verbose output there, but we should normally just get dots. And in fact, that's what was happening before. Well, either way.
Because you're running the server in the same.
Oh, of course, yeah. No, okay, that's a good point. So let's just do it in a fresh terminal. I thought that was the error. I think the error messages from my validator were so good it looked like the same ones as a professional web server. Yeah, so there we go. If we run it in non-verbose mode, all the mandatory tests pass, as indicated by dots. There are some optional tests, so parts of the filter language that the Python tools don't support yet, that fail. So we could just quickly take a look at what those are by making this more verbose. I don't know why I put 4. I think you can put almost any number more than 0 and this will happen. So everything we'd expect passes, so checking that endpoints actually exist, checking that page limits are obeyed, checking that certain references exist if they're specified by a structure. We then run all the example filters that are in the specification, so we scrape for this. Unfortunately, at the moment, this kind of is just a test that the filter parser works because it doesn't do anything to check that the responses make any sense. And in fact, some of them probably won't make any sense. So one open issue that Casper mentioned is improving the validator to actually give us better feedback as well as making it more modular. We should also be testing use cases rather than testing just examples. And then just to show some failures, so at the moment we don't support this left-hand side, right-hand side comparison of values. We probably never will, to be honest. I don't think that it's something that's particularly well regarded in the spec at the moment. And then perhaps more important things, we don't support nested property queries, nested list queries, where you actually I can't remember what the name of that part is. Is it linked properties or something like that queries where you have this colon syntax that lets you sort of dive into specific parts of a list. So we basically just don't have that implemented. But hopefully these are all optional parts of the specification, so it's not so much of a big deal. And obviously as well, we can run this validator on remote servers. So it's only fair that I run it on mine. It'd be very unfair to run on someone else's. So this did fail earlier on today, but I think it's working again now. And there's a lot of green, so hopefully that's good. The fact it's running slower means I can prove definitively that it's definitely running on a remote server. But now we see that it's passed 80 tests and failed the same optional ones as the test server. So I think that's basically it